here's here's an example of what we call folding, folding and hiding of data. So you can say double click to expand. So we have like this geometric update that actually will push the neighborhood away to make room for the. So for instance, if you collapse, it'll shrink again. Or so you have the idea of double click to drill down, double click to expand. So and you could see, how, or you could say. Sorry, I didn't do it. That's a global layout. But I'll move on to a different drawing. Here's another one with a hierarchy, like with containers or groups. People were talking about groups. And the idea of how do you aggregate or make groups and fold data, how do you collapse data, put it away until you need to look at it. So here's an example of where we combine, like say here, if I select this, I could say, for instance, fold those objects, into a container, and then call incremental layout, and then it'll do a, kind of a dynamic routing against, So it's actually, so we combine. We're doing some further work. We have several steps there, but the idea is with each drawing. With each type of drawing people have, if it's like business process, UML, swim lane process, there are rules in the drawing. So it's not just a simple like graph layout. You actually have to adhere to drawing rules. So we're getting to the place where both layout and diagramming actions will adhere to the drawing rules. So every action graphically should adhere to the. So it becomes a different kind. So so we're moving to the idea of defining style sheets outside of the. So you're defining the type and the types, the graphics, the rules outside of the particular drawing canvas, and then every action has to adhere. So okay. Anyway, that's some simple, and then things like undo and redo of change. So we manage all this for diagramming applications, modeling applications. I'd like to show. Yeah, here's an example of another. I'd like to show the idea of, like for instance, if we just, how our routing and incremental drawing has become very nice over the years. Like if I were to select all the links and just duplicate them, you can see, and I want to do cleanup on that drawing like that. You can see how there's a minimum movement, incremental. It kind of solves like a fancy least squares problem to give you the minimum diagram movement, and it's quite and then fast routing, and tie it all together into a smooth graphic system. So it's and then so that's some example. Here's kind of just a labeled directed graph, and I'll just do some. Just to show, like duplicate it, change the colors so I can see. Do some edit it maybe to pull it down. So you could just to show the technologies it's running here. We solved some problems. How to clean up these. So we do. We actually have rule-based automatic layout in here. So I'd like to show another technique we do. We have a constraint system. So for instance, I could say, well, let's make let's make an alignment in this drawing. I want to say that node, that node, that node. So the idea is you would do this programmatically. You wouldn't do it interactively like I'm doing here. But the idea is you might have, like, I want to show a critical path in that supply chain or something. So I could say, let's just change the color of that. So I want to make a critical path. So I've selected a set of nodes. So I can say, let's make an alignment constraint. Yeah. A new alignment constraint and add the selected nodes to it. Okay. So the idea is you can make rules on top of drawings, like left to right sequencing. You can say these nodes need to be in a group because I have data on top of the graph structure. I want to say these nodes are in the same subnet, or these nodes. So I want to influence the clustering, or I want to influence, I want to show a critical path or a left to right because I want the nodes to be named sorted or something. So here's an example where I've done it, and I want to make a vertical alignment of those, that set of nodes. Then if I do something like, you'll see how the layout respects the request. So it's actually, it's not like simple directed graph layout, it's actually rule-driven control over automatic drawing. And then if I switch styles of drawing, this may not come out well, but I'll run orthogonal layout on the same thing, the same structure. Okay, well anyway, it's not necessarily the best drawing, but the rule is still respected. See that the red nodes are still aligned. So you can do like groups or, just like to show a couple more things. So this is that BBC website linking thing. If I said like how many nodes here, 2,500 nodes, 2,800 links, and just let it run. So just to show the speed. It's not, yeah. So the layout's done now, and it's producing the drawing. So it's just a few seconds, and it's pretty clean, for that. And so so I want to show this higher level product. So the idea is those are drawings, right? You're working with drawings. Now the idea is you have data, and you say, I want to have different kinds of views of the same data. I want a spreadsheet view, I want tree controls, I want diagrams, I want properties. So we have this idea of a designer, and so this thing called Tom Sawyer Perspectives has a design environment. So you can say I have data coming from two places, and I have an Excel sheet that says give me my device, gives me my graph basically, my devices and my links. Another spreadsheet or another source gives me status data. So I've got two sources of data. I want to pull them into the same app, and then I want different kinds of drawings of that same data. I want a network map view. I want a device tree, a device table, so I want a device tree control to show like the types, the region, maybe the building that the nodes are in or something. And then I also want inspector to, if I click on a particular node, give me the properties I care about, like IP address or link speed or whatever. So you actually want to work with the data that's in the network. The data that's in the network, and you want to bring it to the screen. So the idea is that you define schema, which says these are the allowed, my nodes have type, my links have speed or capacity or whatever. You say the properties you want to allow in the application. So anyway, here I'm saying I've got schema, sources, and I want graphical views. So then we have the idea of a previewer. So this is a pre-made application that pre-places those components and then loads the data. So what you see here is, so what this Tom Sawyer Perspectives does is lets you graphically configure like tree controls. Like here I say, well, I want locations and types in my tree control. So you can configure the structure of a tree control. You can configure. So I can say, my data has different locations in it, sites, buildings. So the data is showing the type of data, showing the names of the buildings or the sites. I want to show my node types like router, firewall, bridge, switch. So and then the tree control is grouped by that type of data. So if I open up the router, if I drop down on the router, I can click on it, and you see what you get is synchronized views across. So no matter where I click, everything, if I click over here on the spreadsheet, everything's, so everything's synchronized, or here I've got two things selected, and I've got two things selected. So everything ties together visually, which is very nice for, you can have as many graphical views as you want, and you can do it in a few hours. You can build something very fancy in a few hours. So I want to show a little more. So anyway, you can see as you've got the same automatic, the visualization software is a component of this thing. You can do you see the overview facilities again, the automatic layout again, within a particular, you can see, the animated automatic layout. And so, yeah, you can build, these kinds of data. So this is now a data-driven graphics environment instead of nodes and links. So it's not just graphs anymore. It becomes data-driven graphs or data-driven drawings. Here's an example where the tree, we can actually make the tree control behave like a graphical legend to show color and maybe how much load is on a particular link, or you can actually, I mentioned something called filters. You can say, let me go back to the original drawing. The idea of, you can build graphics, so because all the views are synchronized, every action goes back to the data model, and then the views are dynamically updated, you can make a tree control behave like a filter to filter your data. So you say, well, turn off I'm only interested in the East Coast's network congestion or whatever, turn off the West right now. And now you've got a new view over here that shows just the East Coast nodes based on the data. Or you can say, turn off, like for devices, I don't care about phones and laptops or printers. I just want the core, I'm starting to care only about the core network elements that I want to see those. And then, for instance, clean up that drawing, show me. But the idea, yeah, and then we have this idea of, filters that, here's an example of generating groupings based on, like, the data itself. So I'll make nested views, like that says make a nested view based on the West and East Coast. Make another grouping by the buildings the nodes are in. So, so these are dynamically generated drawings from the data. So it's a hierarchy that's generated dynamically. So we don't have to store this graph structure until we actually process the data model. So it's kind of, yeah. Am I finished? Oh, okay, yeah. Anyway, so I guess I'll finish. Yeah. Okay, thanks.